Okay, so continuing looking at 4.3, we're going to look at solving some trig equations. How can you measure the angle when the value of the trig ratio is given? To reverse the process, for example, to determine theta, if you know what sine theta is, we use the inverse trig function keys on the calculator. So if you're told that the sine of theta is 0.5, then we go second function sine, which will give us sine to the -1 of 0.5, and that will give you the answer as 30 degrees. But that would only happen if your calculator was in degree mode, which mine is. So if I go second function sine of 0.5, you get your answer of 30 degrees. Now, this comes from the unit circle. You can also get it from the unit circle, right? Because at 30 degrees, with the angle being 30 degrees, we know the coordinates there are root 3 over 2, comma, a half. If the sine of theta equals 0.5, that's right there. If you work backwards, that means the angle theta is 30 degrees. Okay? But we also know that angle of 30 degrees could also be written as pi over 6 radians. So if you use your calculator and you change it into radian mode, and now if you go second function sine of 0.5, you get that irrational number, which is equivalent to pi on 6. So if you're in the radian mode, it gives you your angle in radians. If you're in degree mode, it gives you your angle in degrees. The only problem with using radian mode is that your calculator gives an irrational answer. The unit circle, though, could be used to get an exact value, pi on 6 radians. When theta is pi on 6 radians, the sine of theta does give you positive 1/2. Okay? So, this is what we're going to do. Note that sine to the -1 is an abbreviation for the inverse of sine. Do not confuse this with sine of 30 all to the power -1, which means the reciprocal. So the calculator keys sine to the -1, cos to the -1, and tan to the -1 return one answer only. But there are often two angles with the same trig function value in any full rotation. In general, it's best to use the reference angles applied to the appropriate quadrants containing the terminal arm of the angle. So it says, determine the measure of all angles that satisfy the following. Use diagrams in your explanation. We want to know, where does the sine of theta equals 0.879? In the domain, their theta is greater than or equal to 0, but only less than 2 pi. So there's a couple things you need to look at here. This domain is important. It tells you two things. The first thing it tells you is where your answers could lie, but it also tells you whether you're working in degrees or radians. In this case, because theta is between 0 and 2 pi, that means that we are in radians. It also goes further to says give answers to the nearest tenth of a radian, so that would be the other reason why we need to be in radians, but the domain really tells us that. Also, if we get any answers where the positive x-axis is where the terminal arm is, meaning the angle is 0, you would state the answer is 0, not 2 pi, because note it says that theta is less than 2 pi, not equal to. And this notation for the domain is the one that's usually used on the diploma exam as well. So you need to always look at that. It tells you what quadrants your angles could lie in, and also tells you what mode you need to be working in. So in this case here, the sine of theta is positive 0.879. To do these, we got to use the CASC rule. In this case, the sine of theta is a positive decimal. So we have to ask ourselves, in which quadrants could the sine be positive? And that would be in quadrants 1 and 2. So this is where our terminal arms would lie. Somewhere in quadrant 1, somewhere in quadrant 2. Those two rotation angles will have the same reference angle. Remember, the reference angle is between the terminal arm and the x-axis. The reference angle will be there, and they will be the same in each quadrant. To find out what that reference angle is, we're going to use our calculator. We're going to make sure we are in radian mode because that's what mode we need to be in to get answers between 0 and 2 pi. And then we're going to find out what the reference angle is by going second function sine of 0.879. There's our reference angle. It says round to the nearest tenth, but you should remember that you shouldn't round until you get to the final step where you actually state your actual rotation angles. We'll round those to the nearest tenth, but we're going to keep a few decimals for our rotation, or excuse me, our reference angle. That would be 1.07, let's say 38. 1.0738. 1.0738. There's our reference angle. So to find our rotation angles, the first one will be the reference angle, which, if we round to the nearest tenth, would be 1.1. The second one, though, in quadrant 2, is 1.0738 radians short of going halfway around the circle. The second one will be found by going pi minus that decimal, 1.0738. And again, we rounded that number off to write it down, but we're going to use the entire value in our calculator. So I'm going to store this number into memory slot A. And then again. And now if you go pi minus it, and again you use the entire value of pi minus the previous answer, that second rotation angle would be 2.1 if we round to the nearest tenth. So this will be approximately 2.1. And again, when you don't put any unit there, that means you're in radians. So these are the two angles such that when we take the sine of them in radian mode, we will get 0.879. If you use the numbers you wrote down, you're not going to get 0.879 because those have been rounded. Always a good idea to use the exact values that are in your calculator. So if we take the sine of the previous answer, that was our second angle, the one in, try that again, sine of the previous answer. There we go. That's that second rotation angle, and it equals exactly 0.879. You see, if you just use the decimal approximation and did sine of 2.1, it's not going to equal 0.879 because you're using a rounded value. Same thing for checking the first angle that we got, which is 1.1. If we just did the sine of 1.1, it will not give you 0.879. You'd have to use the sine of the entire number, which we put in memory slot A. Now you get 0.879. So these are the two angles between 0 and 2 pi, such that the sine of those angles equals exactly 0.879. We rounded them off to write them down, but Using the numbers in the calculator allows us to check. So again, you should never get these wrong. You can always check them. All right. Looking at number 2, where does the cosine of theta equal negative 0.366? Note the domain. In this case, we need to be in degree mode because theta is greater than or equal to 0 and less than 360 degrees. It also says give your answer to the nearest tenth of a degree. So again, we will use our calculator and round our answers to the nearest tenth. But we first start by determining which quadrants our answers could lie in. In this case, the cosine must have a negative value. So if we use our CAST rule, we can see that cosine is negative in quadrants 2 or quadrants 3. There's where our terminal arms will lie, in those 2 quadrants. And our reference angle will be the same. No matter whether you're in quadrant 2 or quadrant 3, the reference angle will be the same. To find out what that is, we have to be in degree mode. And then we will go second function cosine of just positive 0.366. You see, the negative sign has done its job. It told us which quadrants our answers could lie in. So the negative sign has done its job. In order to find the reference angle, which is an angle between 0 and 90 degrees, it's the angle between the terminal arm and the x-axis, so it has to be an acute angle. You're just going to go second function cos of 0.366. So to the nearest tenth, it's 68.5 degrees. To the nearest tenth, our reference angle is 68.5 degrees. Now again, we rounded our answer to write it down, but we're going to use our calculator to find our rotation angles as exact values, which our calculator will give them as, because it keeps all the decimals. We'll have to write them down to the nearest tenth, but we're going to use our calculator to check, to make sure we get exactly negative 0.366. So the first one, let me store first that angle into memory slot A. The first rotation angle, the one in quadrant 2, is 68.5 degrees short of 180. So 180 minus that angle is 111.5 degrees. There's our first answer. Theta would equal 180 degrees minus 68.5 degrees, which is approximately 111.5 degrees when we round it to the nearest tenth. To check that, because it's in my calculator, let's take the cosine of that angle. The cosine of the previous answer equals exactly negative 0.366. So we've just checked that answer. We rounded it to write it down, but we use the entire number in our calculator to make sure that we get exactly negative 0.366, because if you take the cosine of just 111.5, which is a number we wrote down, it's not going to equal exactly negative 0.366. It's close, but it's not exactly, because we used a rounded value. Then for the angle in quadrant 3, that's 68.5 plus 180, because you're going past 180 by 68.5 degrees. So that would be approximately 248.5 degrees, approximately. But again, if you took the cosine of 248.5, you won't get exactly negative 0.366. You'll get something close, but not exactly. To get the exact value to check in the calculator, you would add the entire reference angle to 180 and then take the cosine of that angle, and that will give you exactly negative 0.366. Okay, so again, you should never get these wrong. You can always check them on your calculator. Now again, the negative sign in front of the 0.366 tells us what quadrants we're in. To find the reference angle, which is the angle between 0 and 90, you cannot include that negative sign there. Okay? Because if you go second function cos of negative 0.366, it actually gives you that first answer of 111.5 degrees. But you need the reference angle in order to find the answer in the third quadrant. Not that you couldn't do it, but the calculator gives you the first rotation angle that satisfies the decimal. You need the reference angle in order to find your second angle. Okay? Number 3 says, where is a tan of theta equal to positive root 3? And note the domain here is going from negative 180 to positive 180. But the tangent is positive. So again, that will tell us which quadrants we need to be in. The tangent is positive in either quadrant 1 or quadrant 3. And again, the reference angles will be the same in both of these quadrants. Once again, we are in degree mode. So if we go second function tan of root 3, we get our answer of 60 degrees because that was a value on our unit circle, right? At every stop, we had an x and a y, which was the cosine and the sine value, and then we used them to find the tangent by going sine divided by cos. And you might remember at 60 degrees, where the coordinates are 1/2 comma root 3 over 2, when we did sine divided by cos, or y divided by x, we actually got root 3. But again, in this case, our answers need to be in degrees, so there's your reference angle, always the angle between the terminal arm and the x-axis. And now to find the rotation angle, you have to remember again that we're going from negative 180 around to positive 180. So this angle down here, this rotation angle will be that one there. It's a negative rotation angle. It is 60 degrees short of going all the way to negative 180, which means that that would be at negative 120. Another way of looking at it, if you start at negative 180 and then you go counterclockwise to the terminal arm, you're going to add 60. So there's another way that we get that answer of negative 120 degrees. So that would be the angle in quadrant 3. We also have the answer in quadrant 1, which is just 60 degrees. That's that angle there. And in these cases, you could check them in your calculator. If you take the tangent of negative 120 degrees, you do get an irrational number, but that is equivalent to root 3, same decimal. And if you take the tan of 60, you'll get the same decimal, which is equivalent to root 3. So you should never get these wrong. At least you can always check that all the answers that you get will work. So far, we've seen examples where we only have 2 answers, but it's possible to have 4 answers or 3 answers. It all depends on what information you're given as well as what the domain is. Okay? So for this next one, where is the secant of theta equal to 2 over root 3? And look at the domain between negative 2 pi and positive 2 pi. So you're going to go through the circle 2 complete revolutions to go from negative pi And then if you go in a positive direction, if you go once around, you'll be at 0. And then you have to go another once around to get to positive 2 pi. Also note that positive 2 pi could not be included. So if you had a terminal arm on the positive x-axis where the rotation angle is actually 0, then you could use negative 2 pi as one answer, 0 as an answer, but not positive 2 pi, because the domain tells us that. This also tells us that we need to be in radian mode, because the domain is in terms of pi. And it says give exact answers, which means we're probably going to be dealing with one of those points on the unit circle where we have our coordinates listed. But if the secant of theta equals 2 over root 3, that means the reciprocal of secant, which is the cosine of theta, has to be the reciprocal of 2 over root 3. That'll be root 3 over 2. And the fact that that's a positive value, once again, will tell us which quadrants our terminal arms will lie in. And for that, again, we always use the cast rule. The cosine is positive in quadrants 1 and quadrants 4. So there's are the two places where our terminal arms will be. And to get our rotation angles, we need to know what the reference angle is. It'll be the same for both quadrants. So there'll be a couple different ways you can do this. You might remember from the unit circle. If we put our stops in here, we've got one at 30 degrees or pi on 6 radians, another at 60 degrees or pi on 3 radians, and the one in the middle is for 45 degrees or pi on 4 radians. So again, this is pi on 6, and remember the coordinates there are root 3 over 2 comma a half. Up here at pi on 3 radians or 60 degrees, the coordinates there are 1/2 comma root 3 over 2. And at 45 degrees or pi on 4 radians, they're both root 2 over 2. So again, when it comes time for any quizzes or tests in this chapter, you need to be able to recreate this. You can use your hand trick, remember. So for pi on 6, the root of this many fingers over 2, the root of this many fingers over 2. For pi on 4, the root of this many fingers over 2, the root of this many fingers over 2. And for pi on 3, the root of this many fingers over 2, the root of this many fingers over 2. Yes, sir. Can't hear you. I think it was. I think I did. Oh, you're down here. Sorry. Yeah. But Lanny never did show up, right? Tisk, tisk. All right, so we want to know where the cosine equals positive root 3 over 2. And again, the cosine is the x value. And we can see that occurs when theta is pi on 6. That is our reference angle. So, if we go in a positive direction or a negative direction, let's do the negative one first. Negative 2 pi will be right here. That means you're going to go 2 pi in a clockwise direction, which will end up where you started. But that is negative 2 pi. And so as we work our way in a positive direction, this first angle here would be negative 2 pi plus pi on 6. From negative 2 pi, we're going pi on 6 in a positive direction, counterclockwise. So our answers for theta, the first one will be negative 2 pi plus pi on 6. To add those together, we need a common denominator, which would be a denominator of 6. which means the negative 2 pi would be negative 12 pi on 6. Negative 12 over 6 is negative 2. Plus the 1 pi on 6 gives us negative 11 pi on 6. So there's our first answer. So that is this first terminal arm, the one in the first quadrant, but we're starting at negative 2 pi, and we're going in a counterclockwise direction, so we're adding pi on 6. The next one will be going around almost one complete revolution. It's pi on 6 short of one complete revolution, which would be 11 pi on 6s. That's how far you're going. From negative 2 pi, you're going to add 11 pi on 6s. Again, that comes from its 1 pi on 6 short of 12 pi on 6s, which is 2 pi. So there's our second angle, negative 2 pi plus 11 pi on 6. Again, that negative 2 pi would have to be written with a denominator of 6 so that we can add these together. And that will give us negative pi on 6, which makes sense because if you start at 0 here, let's say that instead of starting at negative 2 pi, we say we're starting at 0, you're going to go pi on 6 in a clockwise direction. That is negative pi on 6. So there's our second rotation angle. Those are the ones between negative 2 pi and 0. But now we have to get the ones between 0 and positive 2 pi. The first one would be pi on 6, positive. So that's the rotation angle in the first quadrant, starting at 0 now instead of starting at negative 2 pi, as well as the one in quadrant 4, starting at 0. Again, that is 1 pi on 6 short of a complete rotation, which would be 12 pi on 6s. Take away this 1 pi on 6 is positive 11 pi on 6. So there's our 4 answers. We can box them just so we're indicating that these are our 4 answers, which again we can check. I would check using the cosine function. There is no secant button in our calculator. The cosine must be root 3 over 2. So let's find out what root 3 over 2 is as a decimal, just so we have that fresh. Whoops. Root 3 divided by 2 is 0.8660. So the cosine of each of these angles in radian mode needs to be 0.8660. Again, we need to be in radian mode because that is how our angles are being stated. They are being stated in radians. So the cosine of negative 11 pi on 6 should be that 0.860 decimal, and it is. The cosine of negative pi on 6 should be that same decimal, and it is. As well as the cosine of positive pi on 6 and 11 pi on 6. So whatever answers you get and write down, you can always check to make sure they're right. So you should never get the stated answers wrong. The only thing that you might do is maybe forget some of these. Maybe you only do the ones that are positive and you're forgetting about the negative ones because you missed the domain. You missed that it's going from negative 2 pi to positive 2 pi. Right? So that's something that you always want to take note of. Okay. So these are the questions that you're going to work on. I'm going to give me a few minutes. We're going to go through the transformations test. Just give me a few minutes to get that set up, and then we'll do that.